Unit 2, Lesson 6, Part 1, the product and quotient rules. So in Lesson 5, we learned the basic derivative rules. So what if our functions are a little more complicated, that we don't want to have to rewrite them, or maybe we can't because the functions are of such a nature that they can't be rewritten into a form where we can use our basic derivative rules. So as I said here, in our derivative toolkit, we're ready for the power tools. So the first one is the product rule. So what the product rule shows you is that you can do it in parts, so to speak. So it's the derivative is the first times the derivative of the second plus the second times the derivative of first. So here is what's considered the first function, and here is the second function. So you have the derivative of the second, so the first times the derivative of the second, that's what you see here, plus the second times the derivative of first. Or sometimes it's said f prime g plus f g prime. Okay, so you can also interchange these two terms because you have plus. Now you're not going to be able to do that when we get to the quotient rule, but for now, if you can remember it the other way, that's fine too, because both work, because we have addition. So it's f prime g plus f g prime. Okay, so let's look at some examples. So you could, for number one, multiply it together and then find the derivative. Sometimes it's quicker that way, just depends. But we're going to start with this simple product rule. So what we're going to do is we're going to find f prime, and our first function is going to be the 2x minus 1, and our second function, our g, so to speak, is going to be our x minus 4. So it's derivative of the second times, so it's f prime g plus fg prime. Okay, it doesn't, see if you notice that in both of these ways here that they have it backwards from the actual definition. So honestly, I just remember it the other way because of the quotient rule, and I'll get to that in a minute. But so I'm going to do f prime, which is going to be 2 times g, which is x minus 4, plus f, which is 2x minus 1 times the derivative of g, which is going to be 1. So I have here f prime g plus f g prime. So I get f prime of x is going to equal 2x minus 8 plus 2x minus 1. So simplifying this, we get 4x minus 9. Okay, so that one, it probably would have been just as quick to FOIL that and take the derivative using the power rule. So let's look at letter B. It's a little more work to actually multiply it together. So we're going to do f prime first, so that gives us 2x plus 3. And then we're going to multiply that times g, which is 2x squared minus 5. And then we're going to add to that f, which is x squared plus 3x minus 1, times g's derivative, which is going to be 4x. Then we're going to multiply everything together. So the first two binomials multiplied together give us 4x to the third plus 6x squared minus 10x minus 15, and then the second multiplication gives us 4x to the third plus 12x squared minus 4x. Putting all our like terms together, we get 8x to the third plus 18x squared minus 14x minus 15. Okay, next two. So constant's a constant, so you can just keep it with the sine x, or you can pull it out in front, however you want. I'm going to leave it in, and then I'm going to show you that the answer can be written with the pulled out in front. So y prime is going to be your f prime, which is going to be 2 cosine x. We can make that as part of the f function, times cosine x, plus 2 sine x times the derivative of cosine x, which is minus sine x. So y prime can be written this way: 2 cosine squared x minus 2 sine squared x. Or if you had pulled it out in the beginning, and you can see it here, you can just factor out the 2. So you could have pulled out the 2 in the beginning, or you could leave it in. It doesn't matter. Okay, finally the last example, g prime of x is going to be the derivative of the first, which is going to be 3e to the x minus 2x, times the second, which is x to the third minus 1, plus the first, which is 3e to the x minus x squared, times the derivative of the second, which is 3x squared. Okay, so multiplying this out, you get, and you have to look at what's being asked for in the problem. Sometimes you don't have to multiply them out. So you get 3x to the third e to the x minus 2x to the fourth minus 3e to the x plus 2x. And then the second set of multiplication is going to give us plus 3x squared e to the x minus 3x to the fourth. Putting our like terms together, we get negative 5x to the fourth plus 3x to the third e to the x plus 3x squared e to the x minus 3e to the x plus 2x. I think I got all the terms there. I think that's all of them. Okay. All right. Since multiplication and addition are both commutative, the product rule is hard to mix up unless you misunderstand the rules. It's easy to get it. Just take turns, one derivative at a time for each term. Just be careful. Don't do what is listed at the bottom. It is not just the derivative of each of them multiplied together. That is not what it is. You have to do the product rule. You have to follow the rule. Okay, now the quotient rule is a little different. You have to be careful with the order because of this minus sign right here. It is always the second times the derivative of the first minus the first times the derivative of the second, and the whole thing is divided by the second squared. And you want to make sure that you acknowledge the fact that your derivative of g, actually derivative of g and g cannot equal 0. Okay, and this is a little mnemonic. I'm not big on mnemonics, but I put it in here. It's high in the fraction over low in the fraction. So it's low d high minus high d low over low d low. I'm sorry, just low low. Okay, and you have to remember low can't equal 0. I was never one for mnemonics, but if they help you, you know, that's great. All right, so I'm going to do the first two of these, and then let you guys do the other two, and I'll write the answers. Okay, because hopefully from the product rule you can get the idea of this. So g prime of x is going to be the derivative of the numerator times the denominator. So x minus 5 times 6x squared plus 8x minus f, which is in the top, 2x to the third plus 4x squared minus 7 times the derivative of the denominator, which is going to be 1, This is all divided by x minus 5 squared. So g prime of x, multiplying this out and simplifying it, we get 6x to the third minus 30x squared plus 8x, and then minus 40, I'm sorry, oh yeah, 8x squared minus 40x. And then our second, all we're going to do is just change the signs of anything. So we have 2x to the third minus 4x squared plus 7. And this is all over x minus 5 squared. So simplifying this, putting like terms together, g prime of x is going to be 4x to the third minus 26x squared minus 40x plus 7 over x minus 5 squared. And you never, it's rare if ever you multiply, expand the denominator, because most of the time you're going to want it factored anyway, because if the numerator simplifies in such a way that you can simplify the entire fraction, you need factors. So it's a waste of your time to expand the denominators. Okay, so I am going to do letter C next, because I think you guys can handle B and D without any problem. But letter C, we're going to have an issue because we're going to have a fraction in a fraction. So I'll tell you what is normally done in that case. Okay, so we have ln of x divided by x minus 2. So f prime of x is going to equal x minus 2 times the derivative of ln of x, which is 1 over x, minus ln of x times 1. And that's all divided by x minus 2 squared. So what we have here is we don't have too much we can put together, but we have this factor of 1 over x. So how do we get rid of that? Well, what we're going to do is we're going to multiply the entire thing by x over x. So that'll cancel that out. So our final answer is going to be x minus 2, because the x's will cancel, minus x ln of x all over x times x minus 2 squared. So just cleaning this up a little. If we want to put it in a different order and make it look a little nicer, you can write this as x minus x ln of x minus 2 all over x times x minus 2 squared. If you want to factor out that x in the top, you can, but there'd be no reason to, because you can't, cancel it out anyway. Okay, so pause the video, take a minute and do B and D, and then check your answers. Okay, so here are the answers for part B and part D. Now for part D, if you didn't get this exact answer, go back and look what you have, and you'll see that there are things that you can factor out, change, use trig identities to simplify that fraction. And you always want to look for those when you're dealing with trig derivatives. Okay, at the bottom here, I again caution you about not just making it the derivative of the top over the bottom. So be careful with that. Also, here's another mnemonic. High d high minus high, I'm sorry, ho d high minus high d ho over ho ho, if you like mnemonics. Okay, so let me do example 3, and then we'll continue this discussion in the second video. So this always wraps around to one of the major topics of calculus, which is finding an equation of tangent lines, so we can find how a function's behavior is, so we can see what rates of change are there to help us explain phenomena. So that's why we're always going to be wrapping back around to that tangent line. So for this, we want to find the equation of tangent line to the graph of f at 0, 1 for f of x equal to cosine x over 1 minus sine x. Now the nice thing is I already have the value of the point, so I just have to find the derivative and then evaluate it at 0. So I have the slope of the tangent line. So let's use the quotient rule to find the derivative. So f prime of x is going to equal the denominator 1 minus sine x times the derivative of the numerator, which is negative sine x, minus the numerator, which is cosine x, times the derivative of the denominator, which will end up being negative cosine x. And this is all over 1 minus sine x squared. So multiplying some things out, I get negative sine x plus sine squared x plus cosine squared x all over 1 minus sine x squared. Okay, so I hope you see the trig identity in the numerator right here. That's going to equal 1. So in the numerator, I now have 1 minus sine x over 1 minus sine x squared. So I can cancel out one factor of 1 minus sine x. So my derivative becomes 1 over 1 minus sine x. So now I have to find f prime of 0. So I'm going to substitute 0 in, so I get 1 over 1 minus sine of 0. So I get 1, because sine of 0 is 0, so I have 1 over 1. So now I can write the equation of my tangent line. So y is going to be my slope of 1 times x minus 0, so I just have an x there, and then plus 1. And as I said, we'll continue our discussion with the other 4 trig functions, deriving those derivatives using our quotient and product rules.